Hey, good morning, everyone. Welcome to a Panzura webinar. I'm Petra Davidson, he's Glen Shok, and this is one data set to rule them all. And we're talking NAS, consolidation, and storage standardization. Doesn't sound that exciting until you realize what organizations are faced with today. One of these things is lack of visibility into siloed data. This sounds kind of innocuous, but it's not uncommon for IT teams to have absolutely no idea what they're storing. There is so much data out there, it's in so many different places, that they literally know very little about it. The one thing they do know quite often is that they don't really dare delete it. And so that means that data just keeps on growing. That makes the problem worse, obviously, and it also increases storage costs as you go along. Everybody's aware of the ever-present threat of cybersecurity breaches, but nobody really appreciates until this happens to them just how bad it can be. It's not just ransomware either. Ransomware might account for around 80% of the breaches, but in actual fact, insider activity can be just as big a problem, and it's much harder to detect. Data resilience and business continuity is a constant challenge. Anything that happens to your data, if you cannot get that data back and you can't keep rolling with minimal disruption, then you risk putting a serious dent in your business productivity and potentially also your job prospects. As organizations get more and more distributed, global file synchronization becomes incredibly difficult. It's one of the most challenging things for any IT leader to achieve what seems like impossible: immediate file consistency, regardless of where your people are and regardless of where your processes run. It's also really not possible for a human being to keep up with constantly changing regulations. If you can't see your data in the first place, there's very little likelihood that you're going to see when you slip out of compliance until you get investigated and you get hit with a fine. And finally, no webinar would be complete without talking about AI. As we all know, garbage in equals garbage out for data. And so it's never been more pressing for organizations to figure out how to securely serve up quality data, and that means unstructured data, to AI. And that's one of the things that we're going to be talking about. So in this presentation, I'm going to talk to you about what's wrong with having multiple file servers, what good file services actually look like, and why the cloud by itself is not the answer. Then we'll talk to you about how to actually fill that cloud gap. And that means how to get files into the cloud efficiently, how to consolidate data that's scattered all over the place, how to make it possible to synchronize files globally, boost your data resilience, and then finally, how to cut costs. So clearly we need to start with some statistics. According to Statista, we're looking at 394 zettabytes of data by 2028. And that's a particular problem for enterprises because their storage requirements are growing at a little over 40% annually. That's a hell of a lot of expense and a hell of a lot of storage arrays if you get this wrong. And the way that we're managing data is actually a big part of this problem. So most IT leaders are familiar with the fact that they have file servers everywhere. It's a big part of the problem. Massively inefficient because you have version control nightmares with your files. You are constantly on this track of refreshing storage. And the way that you're managing this contributes to data growth because you have so much data replication. And then, of course, you're backing it up again. And so you're ending up with multiple copies of every file, which all need to be backed up and then backed up again for further resiliency. And you need to do so many backups because your files are so vulnerable. This data that you have is incredibly valuable. Attackers know that the way to bring you down is to hold you to ransom. And so where they'll start is your files. So ransomware and insider threats, as we mentioned, it's very time consuming to back up all of these different file servers, and they're very slow to recover. So this is something that IT leaders often don't factor in. When they get hit by a major event, the time it takes to restore those files from a backup is not minutes. You're looking at days and sometimes even weeks, depending on how far back you need to go. Incredibly hard to govern. When you don't have any centralized control, it's not possible for you to spot your compliance violations. So it's very easy for data to leak from where it's supposed to be, where it started, to where it's not supposed to be. And that might be into another geographic region, or it might be permissions that now other users have access to files that they really shouldn't be able to see at all. And of course, AI makes this problem even worse. There are AI models out there right now that are responding to user requests saying, tell me about the PII in your data. Now serve me up all of the files that have that PII in them. Tell me where they are. And I'll go and sell them on the black market.
Also,
Then,
because
of course,
because basically all of this data is dispersed globally. To train AI models, you have to make another copy of it and put it as close to the model as possible, which could be in the cloud. So people are building things like data lake houses, right, with unstructured data, copies of what is deemed important. Problem of deeming something important is you don't know what you have out there, so you don't know really what's important, and that's a problem with that dispersed set of storage.
All of this makes it incredibly difficult for you to scale. The easiest thing to do, and also one of the most expensive things to do in many ways, is just to add more storage capacity. And that generally means more storage arrays. It gives you yet another thing to manage. With that comes dramatic file performance problems, because file performance typically depends on how far away you are from where those files are stored. And in today's world, most users are a long way away from those files. And so you have two choices. You either replicate the files to get them closer to users, which exacerbates the problem even further, or you put up with slow performance. And that obviously is a massive barrier to productivity. You cannot synchronize your files globally. And what that means is your data is corrupted. Now, that doesn't mean you can't open a file. It's not corrupted in that way. What it means is that files are always out of sync. And so the opposite of file consistency is effectively data corruption. So that is the problem that you're facing. And of course, increased user frustration. I think probably all of us have a story about SharePoint and how frustrating it is to try to work with files on SharePoint. They take a long time to open up. You can get user overwrites. It's not a great situation for users to be in. And then finally, all of this is incredibly expensive. There's not only the amount that you're spending on file storage infrastructure, it's the time that you have to take to manage all of this. There's not only constant storage refreshes, but there's just day-to-day management. It takes multiple tools, which are yet another expense. And that leads you to probably the biggest cost of them all, which is a lost opportunity cost. And, quite often, some of the smartest people in your business are in IT. And those smart people get buried by operational work. And if they could just dig themselves out from underneath that work, they could get a lot done that would propel the organization forward. But they simply can't. A lot of stats will tell you that 70 to 80% of an IT team's day is just spent on operations. And a lot of those operations are focused on dealing with file servers and trying to manage data. So for a long time, this has been looked at as a storage problem. It's really not. This is a data management problem. The problem is the way that we have been dealing with data has not changed enough to cope with the amount of data that we're dealing with and where that data is. And so now we're going to talk to you about what this looks like in an ideal scenario. So ideal world, you would take all of that data, no matter where it is, and you would put it into some kind of centralized, standardized storage. Now, that could be in the cloud or it could be on premises. Object storage is an obvious candidate for this because it's very cost effective and it lets you do some interesting things by way of data reduction. So once you've got your data in this centralized storage, you would allow fast access to it, to all of your users and all of your processes without making copies of that data. So you would literally have the one data set to rule them all. Then if you're going to do that, you make the data resilient against ransomware. And so if something happens to your data, whether it's ransomware or some other damaging event, most of us also have stories about the user that's got a bit excited with the delete button and blown away multiple copies of important files or folders. So you'd put yourself in a position where you could shrug off that kind of damage without a lot of disruption. Then you'd provide visibility via some kind of a unified console so that you could see and understand finally what you're dealing with. And lastly, you'd put yourself in a position where business continuity is paramount. And so no matter what happened, firstly, you'd know that you could retrieve your data. And secondly, you'd know that you could retrieve it without a lot of disruption and without waiting for it. So cloud is an obvious answer. For a decade, it's been the answer that's been touted. But it's not the answer by itself. And that's because there's good bits and bad bits with the cloud. So it does give you centralized management. It does give you access to what seems like lower cost storage, although multiple IT leaders will tell you that moving to the cloud has not given them the cost benefits that they expected and hoped for. And again, that's to do with the way that they manage data. It gives you a lot more flexibility. As you're buying hardware, you know that you can't use all of the space on that hardware for your storage. Cloud changes the game. You're starting to get a lot more usable storage, and you can power up when you need some more without buying a long time in advance. It does reduce some of the management burden because now some of your resilience is going to the cloud provider rather than sitting on your IT team's shoulders. On the downside, though, more than one organization has found that cloud storage is just another data silo, because what they've done is just picked up the data that they have, they've put it into cloud storage, and it hasn't worked out the way that they thought that it would. They also don't realize that file functionality disappears when you put files into the cloud. Nobody really thinks of file locking as being that important until it's not there. It's always been part of the storage landscape, right? And so when it's not there and you have users suddenly overwriting each other, that's a serious version control problem. And that's one of the reasons why this still doesn't enable productivity. It's because cloud by itself can't do all of the things that you think it needs to do. And of course, your data is still vulnerable to attack. So you haven't at this point achieved the things that you really wanted to. So Glenn, we're going to jump to this hype cycle. And this is from Gartner. It's a 2024 publication. And the thing with the Gartner hype cycle is that it tells you what's new and emerging, what people have had enough of, and what's coming into maturity. And here we've got some really interesting pieces starting to emerge as mainstream applications where they previously weren't. Glenn, maybe you want to talk a little bit about the first one, cyber storage.
Yeah, cyber storage is a relatively new concept to Gartner, as they've combined just regular traditional storage with the inherent security capabilities of what you would expect from almost a type of firewall solution, right? So how can we add the security function into a device that is traditionally going to hand you information when you request it, like a NAS box, right? Just show me a directory and give me a file. That's what they were made to do. But now they're going to add another layer on top of that, which is authenticating you not only at the file level, but on the ability to send that file somewhere else, otherwise known as data exfiltration, right? So these cyber storage solutions, such as CloudFS, will protect you against ransomware, right? And that ransomware protection is not only, as Petra mentioned, the ability to revert back to a previously known good, but before ransomware encrypts you, it will also tend to try to exfiltrate that data. So putting those types of security functions within the storage has become a necessity. And although it is on the up curve of the Gartner hype cycle right now, this is what Panzura has been doing for 17 years, right? Is exactly this. And it's good to see that they have created some sort of mainstream adoption to this concept.
Exactly. Okay, the next one we want to call out is hybrid cloud storage. Glen, why do you need hybrid cloud? What happens when you put all the data in the cloud and now you've got your data a long way away from your users?
Right. The further away the data, the higher the latency, the more unhappy the users are. So with hybrid cloud storage, you have some kind of component that is as close to your users as possible. With CloudFS, it is our CloudFS node, which acts as a local cache for what is hot within that file system. And so it really doesn't matter that your data could be sitting in an S3 bucket 2,000 miles away, simply because all of the data that is important to your local user base within that office is most likely sitting and residing locally. And all the changes get pushed to the backend object store. The great thing with hybrid cloud storage is if you have 30 offices, all of those 30 offices across the globe will have different files that are important to them based on their work function. And that set of data will be cached locally to them. So the power of cloud is its availability and its ability to bring up resources very quickly. One of the issues with cloud is it's always so far away. And hybrid cloud solutions solve that problem by basically being local to you with what's important. And then, yeah, you're going to have to wait a minute if you're calling out a file that hasn't been opened in 3 years.
Then the next thing that's cool about this hype cycle is a realization that it's not just about storage. So back in the day, pretty much all of these things on this hype cycle would have been separate pieces of technology. But now we're getting into specific call-outs from Gartner and other advisors saying, look, you need to get yourself into a position where additional services are available via these platforms. Because if they're not, you're right back to one more piece of kit, one more tool to do a whole bunch of things. So that's not just the storage that Glen's just mentioned, but it's other services like data visibility, like governance, and again, what CloudFS has been doing for quite some time. And then the last thing here that's coming together are distributed file systems, and these are now on the slope of enlightenment. Glen, talk a little bit about this.
Yeah, global file systems or distributed file systems have been in the market for almost 30 years now. They're open source versions. And there's been systems out there, open source versions like Lustre. So IBM has had GPFS out there for a long time. So the concept of a distributed file system or a global file system on its own has been a great science project on day one. But it needs to be commercialized because one of the downsides of Lustre is it's very fast, but it will just crash and corrupt your data, which is why it's great for the Department of Energy, right? Because they can rerun the experiment. But you can't run the experiment of your company over again if that data goes away. So it's taken companies like Panzura to add enterprise feature set and reliability to these distributed file systems So now people are asking for it. Enterprises are asking for reliable, high performance global file systems simply because they're tired of the silos and the cost of managing those individual silos across the globe. And they figured out that the global file system or distributed file system is the place to be. Comically, you need this to train AI. You need the performance of a global file system or a distributed file system to train AI. And our competition within that space has come up with a novel idea of separating metadata from data so as to improve performance. And it is novel, but we thought of it 17 years ago. And that is exactly how CloudFS stores our data, so that you can query the metadata locally at the edge, all right, and then actually get the data from the object store where it's actually housed. AI will do the same thing. It'll query the systems for metadata before it actually goes and gets the exact same artifact. So again, this is probably why this is on the slope of enlightenment, because all of these bleeding edge technologies from, I guess, 30 years ago are now people are going, okay, well, this is interesting now because I'm in so much pain that I have to get out of these silos. And that there's enlightenment for you.
I remember when you started at Panzura, 4 years or so ago now, you said with some surprise, this is a global file system that actually works. What did you mean?
Yeah, it's exactly that. I've worked at a couple of startups prior that had storage systems that had a problem basically making a distributed or a global file system because it is complicated to do. The ones that have been out there a long time, like Lustre, the open source, it still crashes, right? Because it is a project. In the enterprise space, you can't have projects. It has to work. It can't corrupt data. So when I first joined, I saw the system as, wow, it works. It's fast enough, right? Which means it's faster than anything else out there. But performance isn't really the complaint from the user base when purchasing a system specifically for the enterprise. It is, will this be resilient, right? What happens in this failure scenario, that failure scenario, the next failure scenario? And CloudFS, even 4 years ago, could survive the majority of them. And the most recent release of 8.5, it's added additional really unique enterprise feature set to survive any failure scenario, simply because we support multiple object stores now across various regions. So you could have intentional or accidental, just full deletion of object stores, more than one, right? And that would be intentional at that point. And CloudFS can still survive that. Whereas that was really the one weakness. Even with cloud mirroring, if you have the same admin have rights to both, that's an issue. Now that you can make multiples and ensure that the same admin doesn't have the ability to log into all of those, you can survive really anything. That's a big thing. And with Instant Node, we've dropped our cost of high availability at the edge simply because we can utilize whatever resources. And again, enterprises need that. They don't like having a active passive standby set at the edge because you're paying double for hardware.
Got it. Okay, so you can see on this hype cycle, we've got 4 things that are coming together, and ideally you're going to have them in one platform. So you've got storage that's incredibly resilient. It has the ability to tell you that there's some kind of threat happening right now. It can stop it. It can roll back any damage. It can tell you what was damaged, and it can help you report out on it. You've got hybrid cloud storage. So you've got storage flexibility, but you've also got your local feeling performance. You've got additional file data services, which means you have tools to be able to see your data, work with it, manage it. And then finally, you've got distributed file systems. So this recognizes that you've got users and processes all over the place, and you need to be able to take the storage that you've just developed and make those files available wherever people happen to be. And so what does this look like for Panzura? Well, it looks like a hybrid cloud file platform. And that platform is called Panzura Cloud FS. Now, we're going to talk about the core of the platform today. And you'll see there are extensions that extend the capabilities of this platform, but let's stick to the storage aspect of it. So this platform allows you to migrate files into the cloud or other object storage. Let's just call it centralized storage for now. It does a deduplication on the way. And once it's consolidated all of that data, it then can distribute those files locally to all of your users and processes wherever they may be. And it can do this so fast that it actually enables cross-site collaboration. So users in one location in the country can be working on files along with users in another location as if they're all sitting together. And this isn't just across a country, this can be across the globe. It makes data immutable. And what that means is that the data effectively can't be changed, which means it can be rolled back using immutable snapshots, which capture a point in time. It encrypts it to a very high degree, and so it can't be read if it's intercepted. And it also gives you some greater data availability by way of cloud mirroring, which Glen mentioned a little bit ago. CloudFS allows you to put this data in public cloud, so you could use AWS or Azure Blob, private cloud or on-prem. And so it's entirely up to you how secure you want your deployment to be. The point is that these are object stores and it's your choice. So let's talk about the first part of this, consolidation and deduplication. So we said that managing data in the way that we are is part of this data growth problem. That's because most file systems exist to just make copies of files. They don't break them into any other blocks. They just take files and that's it. CloudFS does this differently. CloudFS is effectively doing the translation of files into objects. And so what that means is for the user, it looks like a file. They're just working with a Windows file share. They create a file behind the scenes that gets broken into blocks. And then once you have blocks, you can compare those blocks with what's already in the file system. And when you see a duplicate, then you can strip that duplicate out. So let's take, for example, this PowerPoint presentation. This is not the only one of its kind in our file system. Trust me, most of these slides have been in some form or another in other presentations. And so what that means is I don't need to store a copy of this 7 meg file multiple times over. All I need to do, whilst I might look like I'm saving the file, is store the blocks that have changed. And so there's a new graphic on this slide, for example. That's a new block because the file system's never seen it in this context before. However, 90% of the pages on this might be the same as another slide, another presentation that I've created. Therefore, they don't need to be saved again. So now we're not talking about maybe 4 iterations of a 7 meg file. We're talking about one 7 meg file and iterations that are hundreds of kilobits rather than megabytes. And in doing this, across the board with CloudFS, we get an average of a 35% saving on storage volume. And that's across all industries. This ranges up to 80%, depending on the type of data that you have. So for example, there's not a lot of duplication that can be stripped out of video files. There's an enormous amount that can be stripped out of things like Office files, PowerPoint presentations, and so on. So as part of this process, we do the deduplication, we do it in line. And what that means is as files are being changed and edited and created, we're looking immediately at what else is in the whole global file system, regardless of where the data originated, and stripping out blocks on that basis versus doing it on a localized basis. Then we're putting those blocks into chunks, we're encrypting them, and we're placing them in the object store. And so at this point, not only have you taken data that's been distributed in multiple locations and consolidated it, you've stripped out all of the redundant data blocks, and you've simply created metadata pointers that tell the file which blocks comprise that file at any given point in time. So there's no change to the user, it just looks like a file. Behind the scenes is something dramatically more efficient. And so you're not storing redundant data. Now, CloudFS does this a little bit differently than others in terms of our granularity. And so the smallest amount that you can get these data blocks into is 128 kilobits. That's tiny on the basis of the file size that we have these days. And so what that means is you're literally squeezing every available byte out of your data. We're not the only ones who do deduplication, but you'll find if you do it at the 1 megabit level or the 4 megabit level, then obviously you get far less efficiency. So now we've dealt with this consolidation. We've already got some more efficiency because we've stored far less data. And we're going to talk about distributing those files globally. Now, the good old FedEx truck, believe it or not, is still widely used by enterprises as far as getting data, large amounts of data from one place to another. It is faster and it is cheaper to put it on a truck and ship a hard drive than it is to get large files across the country or across the globe. Now, how many of you have operations in places like India, for example, where they need access to your files, and it's very difficult to get access in a timely fashion? And so here's how CloudFS does this. So at the center of this distributed file system, there is your object store, and it can be the object store of your choice. Pretty much as long as it has an S3 connector, it will work with CloudFS. Here are some of the popular ones, ranging from Google Cloud and Oracle Cloud all the way through to Azure, AWS GovCloud. There's a mix of on-prem and cloud storage. Then you would set up your locations. Now, in this example, we've got 6 locations. You'll notice the one on the left is actually a cloud region. So this is not a physical office location. It's simply a region that has a number of users close enough to it that they're going to get some performant access. And at each of these locations, first of all, you're going to connect these locations. Now, this is a unique architecture of CloudFS. It is typical in a distributed file system to have a hub, which is the object store, and spokes, which are the regions. CloudFS, though, has a mesh. And so you will notice that every one of these locations can connect to the object store, but they can also connect directly to each other. And so what that means is as users at all of these locations are doing their work and changing files, there is no dependency on those files being synced to the object store, which it does once every minute. If the user needs to open a file somewhere else, then file changes that have just been made can be negotiated directly between those 2 locations. Now, at each of these locations, we're going to have a Panzura node. This is a virtual node, a virtual environment that to users looks just like a standard Windows file environment. And each one of these locations has a complete copy of the metadata of the entire file system. And so each one knows exactly what's going on minute by minute within the file system. And it doesn't matter how far apart these locations are. One could be New York, one could be Sydney, Australia. It doesn't matter. Every single user, when they need to know what's going on, will get the latest file changes. The entire file system will see minute by minute what's going on. So something else that's unique, and this comes back to what Glen was talking about regarding performance in distributed file systems. It is much easier for file systems to sync change data sequentially to the object store. So at the edge, you have users and processes generating more data. At regular intervals for CloudFS, that's every 60 seconds, you want to be syncing that data into the object store so that it's then accessible to everybody else. If you do this sequentially, so one location at a time, that extends the amount of time that it takes for the other locations to get hold of that data. CloudFS does something that's completely unique. and this is the fastest way to move data around, we do this synchronization simultaneously. It doesn't matter how many locations you have, they all, every single minute, send their data up to the object store. If they have a lot of data, if it goes over 4 megs, then they ship it earlier. And so nobody's ever waiting more than a minute for data. But more importantly, if you need that data, so if a user in one location starts to open a file, and that file has changes that haven't yet been synchronized to the object store because they're only 30 seconds old, then those 2 locations will talk to each other. And the requesting location will say, send me what you've just done. And that will arrive as part of the file open process. And so CloudFS does the virtually impossible. It achieves immediate file consistency globally. What does that mean? It means the files are up to date. And so as a user, you know that if you're opening a file, you're seeing whatever has just been done to that file, even if it was just done a few seconds ago and it was done at the other side of the world. That is the way that you enable phenomenal productivity. Once you can do that, now bear in mind, as you're doing this synchronized, you're actually taking snapshots. So you're capturing data and you're capturing metadata. Once you've done that, you have a global RPO, recovery point objective, of 60 seconds or less. And you have that because you've snapshotted the state of your file system at every single location, every single minute, or more frequently if there's more data, and you ship that up to the object store. And so this effectively gives you a control Z for your data damage. If something goes wrong with your data, your restore point is no more than 60 seconds away. And so let's take a ransomware attack, for example. You have a file, you've broken it into blocks, as we discussed previously, and those blocks are now in cloud object storage. Your original file is a clean file, so it has 4 perfectly clean blocks. Then you get hit by ransomware. Now you've got some file encryption, and the file system's never seen that before, and so it's stored those as new blocks, and it's created metadata pointers that say at this point in time, these 4 blocks, now they're encrypted, damaged blocks of data that make the file rubbish, but this is what comprises the file right now. So now you can see how easy it is to revert back to a snapshot. So we've snapshotted the original file. We've also snapshotted the encrypted file and shipped that up to the object store, but it hasn't touched the original blocks. And so reverting back to a clean file is simply a matter of reverting back to that snapshot. All we're doing is moving the metadata around. So we're taking the old metadata pointers and saying these no longer apply. I want you to use these metadata pointers, which are from 90 seconds ago. And there your clean file is back. You still have the encrypted file. That's still in your file system as well until you clean it out. But you've got access back to your pristine data. So RPO, 60 seconds or less, but also your RTO, your recovery time objective, is incredibly short. Obviously, it depends on how many files have been damaged, but you can see that reverting back metadata, which is exceptionally lightweight, we're talking about a few bytes here, takes seconds rather than having to restore from the backup. So that's where we're going to stop this particular presentation for consolidation. So we've achieved now consolidation of multiple different file servers. We've deduplicated that data. We've cut it right back to only what matters. We've distributed it to users and processes wherever they are, and we've made it immutable and resilient. And Glen is going to talk us through total cost of ownership and how this gets reduced.
Here we have my handy total cost of ownership calculator, and I'll talk you through this. And if you are interested in going through this and comparing it to storage that you have or storage that you're looking at, you can feel free to reach out to us at Panzura or one of our sales reps, and we can walk you through this. So what do you need to know about the total cost of ownership of storage in general? And some of these TCO calculators can include things like full-time employees or power and cooling and other common costs. I've removed that from this simply because I've never seen a use case where adding or removing a storage array causes somebody to get let go, right? They just need to change what they know, and then they can manage that system. So I'm really focusing on the cost of deploying Panzura, CloudFS, relative to deploying any other type of storage array. It could be on premises or in cloud, and then taking into account some things that really matter when buying cyber storage. So there's the Panzura cost of CloudFS, which is our software costs, and we are a software company. We don't sell hardware, which means that you also need to buy some kind of back-end object store. So our CloudFS costs in, let's say, terabytes per year is the unit. Then you can look at back-end object storage costs. So your back-end object store could be an on-premises system, and then it's really easy to do the math. You just take your total cost, divide it by the terabytes, divide it by how many years you're going to own it, 3, 4, 5, and put that number in there. And then I gave an example of how to do the math on like AWS costs for an S3 bucket for the amount of capacity that you have. Then there are some on-premises hardware solutions that are required to deploy CloudFS. Those would be VMs. So you take in the full cost of the on-premises supporting hardware for this solution, as well as if there are any costs to deploy in cloud. So let's say you don't want to do any VMs in cloud, you can just zero that out, and that cost goes away. And then finally, the installation cost of implementing CloudFS. Very straightforward, right? That's all it takes to deploy CloudFS within your enterprise is our software, running on some hardware in as many locations as you want. Notice that we don't charge per location. We charge based on capacity, right? Based on dollars per terabyte per year. So you could have this in 3 sites, you can have this in 30 sites. We don't care. If it's 500 terabytes, it's 500 terabytes. That's it. When comparing to our competition, if you are buying more of the same, and you are putting siloed storage in various locations, then you care about the sites because you are duplicating costs, right? Storage costs, for example. So you have to do the math there, right? What are you paying for that silo of storage, divided by how many terabytes, divided by how many years you're going to keep it. And then that number goes in there. If you are using cloud storage as a backend, then you can add that in there as well. Any supporting on-premises hardware, infrastructure costs, maintenance costs, and all that. So this is a really fair comparison of what you're looking at from Panzura compared to really anybody else. I'm going to skip over this section really fast and go down to the common stuff. Data growth and TCO term. Obviously, if you put the term here of 5 years, then you want to do the math on your storage array of 5 years if you're buying hardware. If it goes to 3, then you can do the math by 3. But everything will get changed when you when you change the term. Data growth, Petra said in this presentation, it's 40% per year. I defaulted to 20, but if you add 40% per year, it basically makes the scale go up automatically for you. So going back, what are the things that you care about when purchasing storage? First and foremost on your mind is migration costs. If you have a silo of storage sitting on the floor for 5 years, then by year 4, you need to consider, where am I going to move this to? So at the 4th year, you have to think about, where am I going to move this to? Because capacity's gotten so huge that it could take 6 months to migrate from one storage array to another. See, what is the cost to do that initial migration? Well, if you're moving off of our competition on the Panzura, it'll cost the same as a one-time cost to move it off the competition to another storage array. But what about the next time, right? If you're staying with what you have, you're going to have to pay that again. But with Panzura, there's no migration costs, right? First of all, your backend object stores will automatically be upgraded by your cloud service provider. Second, if you are listening to this, you can ask our sales reps about it. If you don't like us, we will migrate off of us for free, right? Obviously, you have to still buy the other storage and the whole 9 yards, but our professional services to move away for CloudFS will cost you nothing. What else do you care about? Backups, right? Because we're an immutable file system, our customers don't do backups. They initially do it for maybe a year, and then they go, we're never going to see these. We don't need them. And your retention period is set within the CloudFS file system. So if you have 7-year, 20-year retention, you set that, and nothing gets removed during that retention period. So you still have compliance, especially if you're doing cloud mirroring to a second cloud provider, right? So sometimes your requirements are around being within multiple hyperscalers, right? So it's not all of your data is in one place. If you do cloud mirroring, you can mirror to a second cloud provider, meets that regulatory requirement. So all you have to do is say, okay, do you want cloud mirroring or not? And if you say yes, then the math is here. How much I'm assuming for the cloud mirroring cost for a second object store. However, with our competition, you still have to do backups, and you know what your backups cost are. You know what your backups cost you in a dollars per terabyte per year basis, right? Just because you're moving to CloudFS doesn't mean you're going to get rid of your your backup provider simply because you have other file systems like Windows file systems to back up. But if you do go to CloudFS, you don't have to back us up anymore, but you do have to back up the competition. You know what that costs you, and that money's in there. The last bit could be a little bit controversial, so you can zero this out if you'd like, but it's the cost of being hit with ransomware. You're not worried about it until it happens. And when it happens, it's really painful. I have taken numbers from like the manufacturing industry. The cost is $80,000 per hour to be down due to ransomware or really anything else. The great thing about our user impacted hours is that with our recovery point objective of virtually instantaneous, you'll probably lose an hour of productivity from your actual users. So I put a fixed number of 1, right, as your cost of ransomware, right? Because you're going to be down, right? If the users see that you're infected, they're going to get up, they're going to go to lunch, they're going to go get a cup of coffee, but you can send an email or a text to everybody and say, don't go anywhere. We'll be right back. The system will be online within an hour. Can't say the same thing about our competition, right? People tend to be down for days or weeks. I put 8 hours in here, but if you increase that number to 16, you can see the associated pain. You can see the associated pain of ransomware right there. All right, so I put in that folks will be down for 8 hours, and then it's at least a reasonable number. And then how many incidents have you had in the term of the total cost of ownership, right? So the 5-year term, if you're running it, you can put in 1. If you don't want to do this math, you can just put in 0 and it all goes away. But then you're basically saying, I'm never going to get hit with ransomware and I'm never going to take any downtime. And it is important to forecast that for a true total cost of ownership. So we're going to say 1 incident. And then lastly, it's just the basic stuff like capacity, right? How much capacity are you going to buy? These two numbers shouldn't be the same. Like Petra mentioned, we have a lot of deduplication on our back end. So if we're deduplicating data, the amount of capacity that you're going to have to buy from CloudFS is going to be different than the amount of capacity from our competition. Right? Even though our competition does do dedupe, if you're buying silos, you're going to have replicated amounts of data, right? You're going to have more impact from RAID, all that kind of stuff. And this is going to be raw capacity. Since we're using an object store, we're not going to get hit with any of that. And then how many snapshots? Snapshots are important. Both sides have to do them. Our competition, their snapshots are significantly more expensive, right? And then I've exposed the kind of math that I've done there. So The traditional customer does about 35 snapshots. And when you're comparing CloudFS to almost anybody, we're considerably less expensive for snapshotting because it's built into our system. An actual snapshot isn't going to cost you much. So that's how to run a total cost of ownership, right? What are you paying for the thing? What does it cost to keep running? What does it protect you from, like a ransomware attack? And then all the associated other backup costs and stuff like that. Petra, back to you.
All right, thank you. And one thing to add, I suppose, on your comments about ransomware, I've read multiple studies that say that organizations can't even come close to their SLA for downtime. It ends up being theoretical, and that simply does not survive contact with the real world.
Right. Most folks won't even make it through their failure contingency plans, right? To be able to bring up their secondary systems and things like that. Every test that's been run with a few of my former, when I was on the IT side of things, when I was doing consulting, every year they ran it and it failed. And the larger the organization is, the more improbable it is to pass an audit of their survivability. And this you can do in real time. Just bring up another file system and show that it's capable.
Yep. And that's another huge plug, I suppose, for consolidating data, because when you get hit by ransomware, that's going to spread from one array to another array, and it gives you that recovery effort times however many storage arrays that got hit.
Yeah. And in consolidation generally makes people think that they're putting all their eggs in one basket, right? The way that CloudFS is architected is the metadata sits at every edge location, but a good copy of our metadata also sits and is backed up to the object store. So if your location goes down, it doesn't matter. If one of your object stores goes down, it doesn't matter if you have a cloud mirror in a different hyperscaler. If you're using our regional store capability and you have 3 copies all within different regions of the same hyperscaler, then that region going down doesn't matter, right? So the survivability is implicit within the architecture. And if every one of your CloudFS nodes goes down, that also doesn't matter because you can bring up another one and it will take that clean metadata from the object store that survived. You have to have a lot of intent to bring this system down. And the key is never give one admin the rights to everything. That's it.
That seems like a good place to finish. Okay, so we've talked about consolidation. Watch out for upcoming webinars. We're talking things like ransomware resiliency, where we'll really dig into how we do this, as well as boosting performance. So stay tuned, check out more information at panzura.com, and thanks for listening.
Thanks, everybody.